So we'll start a new one. So I want you to create a new notebook, and I'm going to name it as IQR. So in the Canva, that is in the Explorer. So make sure that you've clicked and everything is in blue. You can see that you have this blue rectangle. Then go to new file and have it as IQR .ipynb for Python notebooks. IQR.ipynb. Are you there? Okay, so we'll have IQR as a technique, and IQR stands for interquartile range, and it's a statistical measure that is used to identify variability and detect outliers in a dataset. So to calculate your IQR, you'll need your 75th percentile and your 25th percentile to get Q to get that range. I don't know if you've noticed, but in pandas, when you are doing the .describe function, you could see 25%, 50%, 75, 25%, 50%, and 75th percentile. So that's typically is the interquartile ranges of the different percentile. Now, one thing that you need to note also is that it only works for numeric data types, okay? So in the case whereby you want to perform an IQR, always just know that it only works for numeric data points. So you can have here some notes. So you can say IQR stands for, IQR stands for interquartile range. And it's a statistical measure that is used to identify variability and detect outliers in a data set. Okay. So to calculate IQR, you need to determine the Q3 and the Q1, which are simply the 75th and the 25th percentile. So where IQR will be Q3 minus Q1. Okay. 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 So we're going to import the necessary libraries in this case. And let's demonstrate IQR. And Markdown. I need a code cell. I know this. So import. Okay. Code cell. Oh, you've not selected. It's okay. So let me first select my virtual environment for it to be detected. Yeah. So import the So say libraries. So import the necessary libraries. Typically, we have NumPy, we have pandas, and in this case, we'll need now to bring in our data set that we're going to clean. And later on now, I'd require you again to go about in your assignment and clean the data set. That is by identifying outliers. And usually you identify outliers visually through box plots, where you're able to see the upper bound, the lower bound, and the median. Okay. Then from sklearn, got data sets. I'm going to import the fetch California housing dataset. Okay. Then you can have just a print statement here, library imported successfully, and execute. So we need to load the dataset and convert into a data frame. Okay. So we're going to load it. Housing equals to fetch underscore California underscore housing as frame equals to true. So this one simply it will give us in form of, then we can have df equals to housing dot frame. Okay, so if we call out our df dot head, let's try to see if it's in form of a data frame. And you can see right here is in form of data frame. Now this is another technique in which you can load your data set, and upon loading, that is from the sklearn library, it's being converted into a data frame. So in the linear regression notebook, we saw on how you can do it step by step. And also here we can see on how you can do it in form of an attribute. So you can see here as underscore frame equals to true. Okay, so it means that upon loading, it will be converted automatically into a data frame. Then df equals to housing dot frame. Then df dot head to inspect the first 5 rows. So you are displaying the first 5 rows of the data frame such that to see whether it was a success. Also with this, you can decide and have rather it's good practice to have a self-documented notebook. So you can have a print statement at the top. So you can say print. You can say top five rows of the data frame. Okay. Then when you print out this, you can see top 5 rows of the data frame. And again, you can decide and have extra here, whereby you uh, can have a separator, maybe times 60. Okay. And you can have something like that. Okay, maybe times 100. So it tends to separate your output. You can have something like that. So for 5 rows, then you can have this separator here for self-documented notebook. So you can have that, and then you can give me a thumbs up to proceed. Janet, are you there? Can I proceed?
Yes.
Okay. Now, as I was explaining on the IQR at the top here, I've mentioned about percentiles and the quick way on how to see your percentiles that is affecting your numeric data points. It's by making use of the dot describe. So you can have df dot describe. Okay. So here you're trying to have a statistical summary, and from that you can tell the dot describe is also a statistical. I mean the IQR is also a statistical measure. So you expect when you're doing a statistical summary for it to also give you the same. So here we are doing a statistical summary of the data frame. And once you execute this, so you get to have this, okay? So you can see here we are having the 25th percentile, the 50th, and the 75th, okay? So you can see it's affecting across all the columns. And the columns that are being affected have to be numeric. You can see right here. Now, how do we apply IQR to address the outliers? So the first thing that we're going to do is we're going to create a function. So functions are created for them to handle repetitive tasks, okay? And in this case, we're going to create a function and we're going to have all the algorithm workflow on how the function should work for it to filter for us the outliers. So we get to apply. We get to apply the IQR method to detect outliers, or rather to address the outliers. Now, uh, we're going to do a calculation of our 25th, the 50th, and the 75th inside the function. Okay, so what we're going to do here is now defining the function first. And the keyword to define a function is the def, okay? And it has to end with the parenthesis whereby you can see we are having a data frame. So later on, you'll see why I had this data frame inside the parenthesis. And because it's a function, it has to have the full colon. Now, after doing that, step number 2 is we're going to create a copy of our data set, okay? So we'll have df underscore clean equals to, sorry for that, data frame dot copy. So it means that we're creating a copy of the data set that we're going to make use of, okay? So we'll have df underscore clean equals to data frame dot copy. And now, because we know that IQR only works for numeric data points, we need to also do that filtration inside the function. So we need to select which are the type of data types that our detect underscore outliers underscore IQR function should be selecting. Okay. So we have numeric underscore calls. So instead of detecting, you can say here remove. Okay, because we want to remove. So you can have numeric underscore columns for columns. So these are variable name. Then we are going to only select. So it will be equals to df underscore clean dot select. Okay, underscore data types. So what kind of data types are we selecting? So we are selecting the integer and the float, because from the df.info is whereby you can be able to tell whether it's an integer or a float uh, data point. So we get to have float 64 and also int 64. Okay, from all the columns that will be listed from the dot columns, only select the ones that have the data type float or integer to be stored inside your variable name numeric underscore calls or any other that you'd like. Now, upon this happening, so now you need now to calculate your outliers. I mean your percentiles. Now, when we did the dot describe, you can see that it's affecting each and every of the columns right there. And remember, we've extracted and we've stored them inside the variable name numeric underscore call. So it means that they're in form of a list data structure. So for you to have to handle each and every of the element in the list independently, then it means that you have to do a looping. So for call in our variable name numeric underscore calls, which is now our variable name that had our list of only the columns that had either float 64 or int 64 as data points. Now you calculate the Q1. So Q1 will be df underscore clean that particular column dot quantile 0.25. So dot quantile 0.25 simply means that is the 25th percentile of that particular column. Then Q3, because you need Q3 and Q1 for you to know your IQR. Then it will be df underscore clean that iterated element, which is now the new variable name call, or even I, if you want to replace here with I here, dot quantile 0.75. Then our IQR will be Q3 minus Q1. Now, for you to determine your lower bound, okay, anything less than this should be, and as an outlier, then you need Q1 minus 1.5. So this is a syntax, it's a formula, times the IQR. Then the upper bound, anything above, okay, this particular value, then should consider as an outlier, it will be Q3 plus 1.5 times IQR. Okay. So after having this, and then now you get to filter the data and keep none outliers. Okay. Now to filter the data, now we need to know that the lower bound has been calculated and the upper bound has been calculated. Now, by an upper bound, I mean if your cap is at 9, then it means like 9.2, 9.5, 10 will be considered as outliers. So so anything greater than the upper bound will be an outlier. And anything less than the lower bound will be an outlier. So if your cap is at, let's say, 3, it means like 2.9, 2.1, 2.0 as data points will be considered as outliers. Now, it will be df underscore clean, okay? Then that particular column, if it's greater than or equal to the lower bound, then that's an outlier. And it has to be, so anything that is filtered, okay? Anything that will be considered as not an outlier has to be greater than the lower bound, but less than the upper bound. Okay. So for example, so in case of, so if you can have that, so then you can have comments. So for example, if we have these particular values right there, then the lower bound is, let's say, 3, okay, and the upper bound and the upper bound is, let's say, 8. Then the values 100 is an outlier because it's greater than the upper bound. Okay. Same to the value, let's say 1 and 2, because they are less than the upper bound. But 3, 4 are not outliers because they are within the bounds. All together, Janet.
Yes.
So that's how. So what you've just done, you've cleaned the outliers. So whatever that is inside the df underscore clean has no outliers. But if you want now to view the outliers, you want now to get the outliers stored somewhere, then it will be the reverse. Okay. So the outlier has to be less than the lower bound and greater than the upper bound. So it will be the reverse of this. Are you together?
Yes.
Okay. So we return our df underscore clean. Then we get to do df underscore no outliers. We get to remove now. So we pass in our df because remember, remove underscore outliers underscore IQR should be expecting a data frame. This one. Okay. And how have we labeled our data frame is as df. So we are feeding it that one because remember this is now a universal one. You can just pick it this way, subject it to another notebook, and it will work as long as your variable name is df, or you can even change. Okay. Then after having that, so we can print. Let's see if it's really printed out the outliers. So we can print the data frame shape before removing outliers and the data frame shape after removing the outliers. And let's see whether it really cleaned. So you can see before removing outliers, we had 20,640 rows and 9 columns. The columns will never change. Then after removing the outliers, now we came down to 16,232 rows. Now, if this works for you, you can feed it to your EDA and have now the model receiving fresh data that does not have outliers because regression models are affected by outliers. Is that okay?
Yes.
Ask me questions. Ask me. Let ask me questions.
I think I have none.
Yeah, none. So I'll expect you also to have the IQR such that before you can define your X and Y vectors, you've cleaned your outliers and then now pass it down to the splitting into the training and testing, and now compare if your MSE is changing. Tomorrow we tackle another type of regression. We have the L1 and the L2, that is the ridge and the lasso regression. They are more of a regularization techniques using alphas, and these alphas also can be determined with different methods. I'm going to show you on how you can do a grid search. That is to do with a cross validation. Determine the best alpha, then see if it's again changing whether we are having improvement to our model. So we'll have covered 3 models. That is the linear regression, the ridge, the lasso. Then now you can have a all complete notebook right from the top. That is importing the necessary libraries, your EDA, data preparation, coming down to your cleaning, outliers, missing data points in case, coming down to the selection of the models. So you did 3 models, that is the linear regression, the lasso, the ridge, and what are your conclusions? What can you say about the whole predictive analysis? So at the end of it, we'll have to combine one notebook. Is that okay?
Yes.
So this is what I had for today. See you tomorrow, same time.
Okay. Have a good day.
You too. I will share these recordings. So
So
I don't know. So should I share in the group or I share to your DM?
you can even just send it to me. That's okay.
So okay.